When selecting a type to use as the lowest level data source for LINQ, Microsoft selected an existing type from the framework class library, the type IEnumerable of T. IEnumerable of T is the perfect interface for hiding the true source of data because it defines only one method. This is the metadata view for IEnumerable of T, and you can see it defines one method called getEnumerator. GetEnumerator returns an object that will let you step through data, one at a time like you would do in a for each loop. So I can take this IEnumerable of string and write a for each loop to go through each city name and perhaps write it out to the console. And although we're working against data that is in memory, it's an array of string, it doesn't have to be. We can hide all sorts of things behind an interface. It could actually be going out to a database and pulling a record back and turning it into an object and doing that each time we come through the for each loop. So IEnumerable of T is perfect for hiding the source of data, but it doesn't do so well at defining interesting methods for querying data. You can only loop through the data source. But instead of defining new methods on this IEnumerable of T, Microsoft took the approach of adding extension methods to the language and extending IEnumerable of T. An extension method is a method that looks like it's a member of a given type, when in reality it's just a static method on a different type. Let's see how this works. In this first sample, I want to add additional methods to datetime. You might recall from the first half of this course that datetime is defined as a struct, and structs are implicitly sealed, meaning it is illegal to create a new class that tries to derive from datetime. You cannot inherit from a sealed class. Inheritance, then, is not an option for adding methods to datetime, which is unfortunate because sometimes I want to add some additional methods that perform calculations on a datetime and reuse that code throughout the rest of an application. Like in this sample, given a date like August 9th, 2002, I want to find out how many days are left in the current month. There is a way to do this using datetime.daysinmonth, but if I want to shorten up that code so that I don't see the calculation everywhere and actually give it a named method, then my only option is a static method on a static class. We'll call it days-to-end-of-month, and it's invoked by using dateutilities.days-to-end-of-month. The static method invocation makes this code a little hard to read because the type name dateutilities gets in the way. If I make days-to-end-of-month an extension method, however, I can make this method appear as if it's an instance method of datetime. And the way to make an extension method is to add the this keyword in front of the first parameter of a static method on a static class. Now, anywhere that I have a datetime, and this extension method is in scope, which means the namespace where that extension method appears is either the same as the namespace I'm in or it's including with the using clause, I can walk up to a date and I can say days to end of month. That's an extension method. You can see it has a slightly different icon here in the IDE. The IDE is telling you it's an extension method, but it is invoked now like an instance method because I no longer have to pass the date in as the first parameter. Extension methods are just a compiler trick. Days to end of month is not really an instance method, and behind the scenes the C# compiler will still generate code to call the static method on the static class and pass in that date as the first parameter. But the syntax is much easier to read. We don't have to see that static type name dateutilities there. We don't have to pass a date as a parameter. Instead, we invoke a method on the date. It looks like an instance method. And this works for all sorts of types. You can add extension methods to sealed types, to built-in types that Microsoft has written, to third-party types, to other types, even to interfaces, as we're about to see. Let's return to the sample that's working with IEnumerable of string. And as I've pointed out, there's really not many interesting things you can do with an IEnumerable of string. You can get an enumerator and use that to loop through the strings, but what I'd like to do is I'd like to be able to write a query that says, take this data source, this IEnumerable of string, and find me all the strings that start with a capital L. Down here at the bottom of the file, we have a static class with a static method inside that is an extension method for IEnumerable of string. And what it allows you to do is to pass in the data source, the IEnumerable of string, and the starting string that you're looking for, and what it will do is loop through each string in that IEnumerable, find the string that starts with that starting sequence that you've specified, and then it will yield return just the matches that it finds. yield return is a way to build an IEnumerable. We'll return to talking about yield return in a later module, but just for now, trust me that builds an IEnumerable for you. The C# compiler will generate code behind the scenes to make the return result an object that implements IEnumerable. So given that definition, I should be able to write code like this. I have a query where I want cities that start with the letter L. So cities.strings that start with and a capital L. Notice right now that is in red, that's a compiler error. And that's because, as I've mentioned before, the namespace that an extension method is in has to be in scope for the compiler to recognize it. Right now, this extension method is in a different namespace than the code that's in our program. But if I add a using for extensions, now the C# compiler can see strings that start with L. And in fact, if we build this program and we run it from the command line, then we get just London and Las Vegas. So what we've done essentially is add an extension method that makes it appear as if there's a strings that start with on every IEnumerable of string. And this is the way that link operators are built. Let me add another using. Let's add a using for a namespace called system.link. System.link is where all of the link operators are defined. And so now if I walk up to cities, I have a lot more options than just get enumerator. I can do things like count everything that's in the IEnumerable. I can also do a where to filter things that are in that IEnumerable. But notice that the interesting thing about where is that it's not saying where it starts with some letter or where the sequence is this short. It's a very generic filter. It's essentially going to allow you to do anything that you need to do to filter that IEnumerable of string. This is unlike the extension method that we've written that really only is good for filtering one thing. It's when you want to filter IEnumerable of string and the string has to start with a very specific string that you specify by passing it in as the parameter. This link operator where is very generic. And the question is, how will where know how to filter something? Where is very good at building up a subset of objects, allowing you to filter out the data, but it doesn't know how you want to filter the data. Before we can understand how where allows us to express that filtering mechanism that we need, we have to look at Lambda expressions first.